we are talking about shadowing in OpenGL. So there are kind of scenarios where, like if we depth test in OpenGL, like if I have a okay, so this is eye or camera, one surface, another surface. Okay, so this surface would not come into the picture. Okay, so that is the scenario. Otherwise, if we don't enable depth testing, then whatever we draw next, it will come into the picture because it is going to the color buffer. So there are kind of three. Frame buffer is another data structure that carry color buffer, depth buffer, stencil buffer. And if we don't enable depth testing, then whatever we do in kind of drawing, everything go in color buffer. So that is the scenario in depth testing. So the kind of the surface that is obscure or that is behind, those would not come into the picture even though they draw afterwards. So that is depth testing. Now what is shadowing? Okay, so this is eye. Here is one light, and here is one kind of we can say one model. Now if light falls, the model that is behind the light, that should not be shown, even though from the eye it is visible. So now there is another guy came shadowing. So one model, one item is obscuring other item. So it is kind of doing a screen effect, and other would not be shown. So how we can kind of achieve that kind of effect? Like if we see in the real world, then if we see lunar eclipse, then it comes behind the scene. So sunlight falls on earth, and that is full moon night. Okay, somehow generally full moon night, if it is sun, earth, then moon will be kind of exactly behind the scene in the east side when sunset happens, but it will be at an angle that earth will be not in between. So that is full moon night. But if earth comes in between, then the light would not fall on the moon, means it will come in a kind of a shadow, it will come behind the scene. So then that cannot be shown. So shadowing, how we can achieve a shadowing in OpenGL? So shadowing is similar to depth map. Okay, so if I have an eye camera that maintains depth, then I have a light that will also maintain depth. So the pixels that are in front of light, they will be lit, they will glow, and behind the scene, they won't let glow. So at the end, whatever the depth map, the depth hashing or mapping, whatever we achieve from the light, and what is the actual through the eye, through the camera, the latter will mix up, will merge. So one hint we are giving to the camera that these places, that these pixels would not be shown, even though they are in front of the camera, but they are coming kind of behind some object if I see from a light perspective. So that we'll see in the discussion that how we can kind of use it like a texture. Texture is nothing but it's a kind of mapping one. So it has texture has a set of pixels, texture. So set of texture we have. So each set of texture we can kind of keep information that so if we see at the end in the frame buffer, everything comes in a set of pixel only. So whatever we see in frame, so it is depth or not depth, it is stencil or color, whatever, it comes in a set of pixel only. So if someone is seeing from the light perspective, then it is like a frame buffer and what he sees. So each pixel would carry the depth information. If a particular kind of a pixel that is in front of the light, then how much depth it contains. So it will contain another texture. Depth map contain from the eye, it contains another text, another mapping. So whatever mapping we receive from the light sources, so we will rotate the projection and model view in the sense that light source become eye, and then it sees. Like we have already seen the depth testing. That camera is the eye, and then it sees which is where. So when we say I want to place model at this coordinate, this coordinate, this coordinate, that coordinate, then it thinks that which all are going to be screened. So that way we will rotate the projection and model view in a sense that light will be light source. The light source will be camera, and then it will kind of it will see from this 2 points. One is the actual camera. Now light is becoming the camera, and we rotate the projection model view. Now we know that in this fashion that which model is at which depth, and then we create a kind of, we'll have a texture, and there we'll fill that these are pixels that should be visible, and these are at what depth, because we know that models are at what depth from the camera's perspective. Now this information, now we'll pass it to the camera, whatever we have received from the light, that these pixels are kind of going behind the scene, so that it will take care, and then they would not come. Later we can display the shadows as per the texture. So we'll see the kind of not very complex, we know kind of projection and model view, and how they change when we place models here and there in the various z coordinate. Then both are z coordinate, either I see from the light or I see from the actual camera. So that we'll